When given on number 30 an angle and two sides, so I am given an angle, a side, and a side. Anytime you're given an angle, side, side, you have to test for two triangles. So whatever is given in triangle 1 will also be given in triangle 2. So now we're going to use laws of sines to solve for angle C. So I'm going to say 24 over the sine of 25 degrees equals 30 over the sine of C. So make sure your calculator is in a degree mode. When I cross multiply and then take the inverse of that answer, I get angle C equals 31.9 degrees. So the next thing we're going to do is we're going to find the supplement of angle C. So whatever angle you find first, you find that supplement. So I'm going to take 180 and subtract 31.9. When I do that, I get 148.1. At this point, I'm truly going to treat each triangle separately. To find angle A, I'm going to take 180 and subtract the two angles I know. When I do that, I get 123.1 degrees. Now I'm just going to use the laws of sines to find the remaining piece. 24 over the sine of 25 equals side A over the sine of 123.1. I will cross multiply to find A. Side A equals 47.6. Now we're going to go and finish the second triangle. I'm going to start with the same thing. I'm going to take 180 and subtract the two angles I know to find the side length or the angle of A. Angle A is 6.9 degrees. Then I'm going to use the laws of sines. 24 over the sine of 25 equals side length of A times the sine of 6.9 degrees. When I solve through that, I get approximately the length of 6.8. We're going to solve. I have two terms, and in common in those two terms, I'm going to factor out a cosine of x. When I do that, I'm left with sine of x minus 2 equals 0. Now I have two factors. We're going to take each factor and set it equal to 0 and solve. On this first part, I want to know where does cosine equal 0? Well, cosine is 0 at the point 0, 1 and 0, negative 1. Therefore, my solutions on this first part are going to be pi halves and 3 pi halves. There's two answers. Sine of x equals 2. Well, the unit circle has a radius of 1, therefore there is no solution if the x value is not in between 0 or negative 1 and 0. This next piece, there's nothing I can factor out. This is no different than solving 2x squared minus x minus 1 equals 0. So we'll just solve this first, and then we'll go back and put the signs in. What I'm going to do is I'm going to change that by multiplying the first and the last term. So 2x squared minus 2x plus x minus 1 equals 0. What I just did is, if I was to add those middle terms together, they're like terms, I would get negative x. And that's exactly what I want here. Now I can factor by grouping. I'm going to group the first two and I'm going to group the second two. In the first two, I'm going to factor out a 2x. When I do that, I'm left with x minus 1. I'm going to factor out the next sign. Since there's nothing in common, I'm just going to use the coefficient 1. Then I'm left with x minus 1. In common, I have the factors x minus 1. Left over on the outside, I have 2x plus 1. Now at this point, I'm going to go simplify and put the sign back in for x. So I have the sine of x minus 1 equals 0. And 2 sine of x plus 1 equals 0. Now I'm going to solve. I want to know, where does the sine of x equal 1? And where does the sine of x, I'm going to subtract 1, divide by 2, equal 1/2, negative 1/2. Well, the sine of x equals 1 only at this point right here, and that point is 0, 1. Therefore, pi halves is the only place that it will equal 1. Sine of negative pi halves. That's going to happen in quadrant 3 and 4. And if I look at my unit circle, where does sine equal negative half? And that happens at 7 pi 6 and 11 pi 6.